Good night, scholars. Welcome back to another live CSEC math class. Tonight we're going to be looking at our formulas and shortcuts series, and our topic is laws of indices. Now, another name for indices, and by the way, index is the singular and plural indices. So another name for the index is power or exponent. So anywhere you see either of those terms, that's what they're talking about, right? Laws of indices. So the index or the power or the exponent is that little digit, that little number that you see at the top right hand side of another number or variable, and the number that is below it is called the base. So for example, if we have
called the base.
If we have x with a little 5 at the top,
So
that the x would be the base and the 5 would be the power or the index. And what that means is it's telling us that we should multiply the x by itself 5 times. A lot of persons confuse the instruction and they think they are to multiply x by 5. No. The number at the top, the index, tells you how many times you are to multiply the base by itself. So there are certain laws that regulate how we use indices, and we're going to go through the basic laws tonight. In studio with me, I want to welcome John, Imani, and Amari.
Good night, Miss.
Welcome, my dedicated in-studio scholars. Thank you always for your time and your assistance. All right, so we're going to start. I have a number of slides that I'm going to be going through, and we're going to be talking about the laws of indices. So on the first slide, I have the 6 basic laws that I'm going to be elaborating on. And number 1 says x to the power of a times x to the power of b is equal to x to the power of a plus b. Number 2, x to the power of a divided by x to the power of b is equal to x to the power of a minus b. Number 3, x to the power of negative a is equal to 1 over x to the power of a. Number 4, bracket x to the power of a bracket raised to the power of b is equal to x to the power of ab. Number 5, x to the power of 0 is 1. Number 6, x to the power of a over b is equal to the b root of x to the a. Now these are all in variable form, right? In letter form. So it will be clearer to you when we start plugging in some numbers, and so you would see exactly what we mean. So let's look at the first 3 rules. So the first 3 rules are demonstration on the screen. Welcome. So the first 3 rules, x to the power of a times x to the power of b is equal to x to the power of a plus b. So what this means is when you're multiplying and the bases are the same, so they are both x, or they're both 5, or they're both -10, or whatever, the base must be the same. The bases are the same and we're multiplying them, we add the indices. That's what this rule is saying. We're going to be doing examples of each rule, several examples of each rule. So if we're multiplying and the bases are the same, we add the indices. Number 2 says x to the power of a divided by x to the power of b is equal to the x to the power of a minus. And what this rule says is if we're dividing and the base are the same, we subtract the indices. So we keep the base, we don't do anything to the base, we just write back the base, subtract the powers, we subtract the indices. Number 3 says x to the power of -a is equal to 1 over the a. So that means if you're raising a number or a variable to a negative power, you're to write the inverse of that base to the power. So you have 1 over that base to the power. Let's go to the other slide. Number 4. So what we're doing here is we're raising a power to a power. So x base, it's in the bracket and it's raised to the power of a, and then the whole of that is also being raised to the power of b. Whenever you have that happening, keep the base and multiply the power. Good night, Zion. Keep the base and multiply the powers. Number 5, x to the power of 0 is true for any number, variable, term, any number raised to the power of 0 is 1. It doesn't matter how big the number is. It doesn't matter if the number is negative or positive. Once it is being raised to the power of 0, the answer is 1. Number 6, x to the power of a over b. So what happens here? Raising the base to a fractional power. So what you do is the numerator, or the number at the top of the fraction, you'll raise the base to that power, and the denominator tells you the root that you're going to find. So you can do either one first. So you'd raise it to the power of the numerator and then find the root using the denominator. So for example, if you had 2 over 3, so you would raise it to the power of 2 and find the cube root of it. So let's get into some examples with real numbers. You can see what we're talking about. All right. So Imani, read number 1 for me and explain how we got the answer.
Okay, miss. Number 1, x to the power of 9 times x to the power of 5 times x to the power of 6 equals x to the power of 20. Miss, so because of the first rule that says if all the bases are the same, we just add the index number or the exponent. it would be 9 plus 5 plus 6, which is 20. So it would be
All
x
right,
to
so
the
we keep the base, which is x. So it's not that we're going to have 3x, right? We
yes,
just
miss.
write back the base because the base is the same. We just write back the base and add the
The
indices.
exponents. Yes, miss.
Right. Okay. Drayshawn, read number 2 and explain.
Okay, miss. Y squared multiplied by 3y multiplied by 5y to the cube. So miss you'd add, miss since the law says miss when you're multiplying, miss you'd add all the numbers. Miss 3 plus 2 and miss the imaginary 1 at the top. So miss it would be so miss it would 6, 3 plus 2 plus 1.
And where the 15 comes from.
Miss 5 times 3. Miss the 5 3 times 3y.
All right. So the coefficients, we multiply the coefficients, right? So the y squared has a coefficient of 1. The y has a coefficient of 3, and the y cubed has a coefficient of 5. So 1 times 3 times 5, that's how we get the 15. And then Drayshawn is saying we add the powers. So the y squared, we add the 2. The y actually has a power of 1. And this is very important. So Drayshawn called it the imaginary 1. So in algebra, when there's a 1, as a coefficient, we don't need to write it, or a -1, we don't need to write it, but we should always remember that it exists. It has a value. Same for the powers. We don't write y to the power of 1, but we must remember that y by itself is y to the power of 1. And in this case, where we're adding the indices, we need to add that 1. So it's 2 plus 1 plus 3, and that's how we got the 6. All right. Who else is with you, Imani?
Miss, could you repeat, please? Who else is you?
Is John with you or Amari?
Oh, yes, miss. John is there and Amari is here.
And are they a part of the
Yes,
class?
miss. Yes, miss.
All right. So John, please number 3
Okay, miss. Number 3.
and explain.
10t, yes, miss. 10t squared times 5t squared. Okay. Miss, yes.
Sorry, say
Okay,
that
miss.
again, John.
Miss, I was saying
So
as
it's
you have to,
5t cubed to the 5th.
it's 5t cubed to the 5th. Miss,
Q to the 5th.
cubed to the 5th. Okay, miss, how they got the 50, so multiply the 10 times the 5. Miss, how they got the 4.
No, they multiply the 10 times the 5. The
Okay,
coefficients.
yes, miss. They multiply the 10 times the 5. That's how they got the 50. Miss, how they got the P to the first one. Mr. Mr. P. Mr. P would be the imaginary 1, so it would be 1 plus 3, and that's how they got P to the first. How they got Q to the 7, miss they add the 2 plus the 5, and they got 7.
Okay. Thank you, John. I don't like the term the imaginary 1. It's not that we're imagining that it's there. It is there. I would prefer the invisible 1. I would prefer if you said the invisible 1. It's there, but we're just not seeing it. Because
Yes.
in math, we have numbers that we call imaginary numbers. And it's different from what you're referring to now. So just so that there's no confusion, if you want to refer to it as something, I would prefer you say the invisible 1. All right?
Yes.
All right, Amari,
Given
how about 4? Read it for me and see if you can how we came by that answer.
Okay, miss. Negative 3xy um cube times negative 5x squared squared y um y to the fourth power.
Go ahead, Amari.
Um,
So how did we get the 15?
Messi said three. I mean negative 3 times -5, and that would give you negative 15.
Okay, so the negative 3 times negative 5 gives a positive 15. And how did
Yes,
we get x cubed?
Messi said x. Messi said x cubed.
The first one is x to the
So
first power.
Messi would say
The first x is x to the first power.
yes.
And
Messi
then
would
the
be.
second x is x squared.
So you would add the powers. Yes,
Right, we
Messi
add
would
the powers.
add.
Okay, because the law says if the bases are the same and we're multiplying, we add the powers. So we add x to the first power plus x squared, x to the third power, or x cubed. And how about the y, Amari? How did we get y to the 7th power?
Messi got y to the 7th power because you.
Because what?
Messi would say y cubed y cubed to the, plus the to the fourth power.
So we add the 3 and the 4.
Yes,
And we get, okay, we get the 7.
yes.
All right, Imani, back to
Okay, miss.
5.
Number 5. 10xy divided by 2x cubed and y to the fifth power. Miss, so 10 divided by 2 would be 5. And for the rule it says when you're dividing and you have the same base, you are going to subtract the first power from the second power by the second power. So the first x would be x to the 1 power, and the second x would be x to the third power. So 1 minus 3 is -2, and the y would be y to the first power minus 5, because there are two y's, and it would be -4. So the answer would be 5 over x -2y -4.
Well, if we're writing it without the division line, we would put 5x to the -2, y to the -4.
Yes,
But
miss.
when
I
we're
thought this
writing it
was
as
the
it is on the
it would be
screen,
negative.
the x to the -2, that's how it end up down the bottom of the division line. Because it's to the negative power, it's the inverse. So that's
Yes,
how
miss.
the x square and the y to the fourth power end up on the bottom because they were negative. So there
Yes,
are
miss.
two ways we could have written it. We can write it as it is now, or if we didn't want to write it as a fraction, we would put 5x to the -2, y to the -4. Okay? So
Yes, miss.
when you have variables being raised to the negative power, if you want to write them like a fraction, You'd put them as it is now on the screen without the negative sign. They would be down the bottom. If you don't want to write them as a fraction, you'd put the negatives in front of them.
So
Dration
Miss,
number
when it's
6.
written as a fraction, Miss, when it's written as a fraction, it should be common.
If it's written as a
Even if
fraction,
it's
you don't
negative.
need the negative power. The powers
So
would be positive, but they would be down the bottom of the division line. All right, Dration, go ahead, number 6.
number 6, 2x to the 4th and y to the 9th over 20x and y to the 6th. So Miss, the law is that calm down. So Miss, you the 2 over this 2x divided by the 20x should be 1 over 10x, and Miss the 4. Miss the law says when you divide them, you should subtract. So Miss the 4, Miss minus the invisible one, Miss with the x3 to the 3rd, and Miss the 9y, y9 minus the y6.
Would give.
Oh, yes, just it would be 3. Here's that.
Okay. All right. All right. John.
Isn't that the same one? Oh,
Hold on. Where's number 7? Oh, I didn't have number 7. I think I forgot to put on number 7. All right, let's move on.
okay. 6x
Oh, I
y.
know. When you're done, I'm going to tell you what number 7 says. But go ahead.
Okay. 6x to 6xy to the 5th power, 3x to the 3rd power, y to the 3rd power equals to y to the 3rd power and x to the 3rd power. If you divide the 6x,
Divide the 6 by 3.
let's consider divide the 6 by 3, and that would give you a 2. Miss, and Miss, how you got one? Y squared, Miss, you did 5 minus 3, which is 2, Miss. And Miss, how you get x to the, x to the 3rd, Miss. If you did 4 minus 1, Miss.
No,
Miss,
not
Miss
4
x,
minus 1.
um,
The one
Miss
at the
1
top
minus
minus the one at the bottom. So it would be 1 minus 4,
x,
which would give
1
negative 3.
x.
So, but because we're writing it as a fraction, we can put it down the bottom as x to the 3rd power. If we didn't want to write that as a fraction, it would be 2x to the negative 3 and y squared. So remember, it's the x at the top minus so that's the 1 at the top minus the 4 at the bottom, which would give a negative 3. So 2 ways we could write it. 2x to the negative 3y squared, or as it is now, 2y squared over x to the 3rd power. Now number 7, it's still on the board. So let me just read it for you. And it says 9 to the 0 power is 1. 2x to the 0 power would be 2, because since x to the 0 power is 1 and 2 times 1 will give 2. 100 to the 0 power is 1. Y to the 0 power is 1. So basically it's telling you any number, any variable raised to the power of 0 is 1. All right. Imani, you do this one. Number 9.
Okay, Miss. Number 9. 4 p to the power of 6 y to the power of 9 divided by 8 py equals, so Miss 4 divided by 8 would be 0. Yeah, 0.5. And p would p to the 6th power would subtract p to the 1 power, because even though the 1 is not there, it would be p to the 1 power, which would give you p to the 5th power, and y to the 9th power minus y to the 1 power would give you y to the 8th power, which is the answer. Half p to the 5th power, y to the 8th power.
Correct. All right, Amari, you can take the other one, number 10.
10 to the negative 1 power. Negative 1 power equal 1 over 10. This got the answer because,
Speak up, Amari.
okay, it's 10 to the negative 1 power equal 1 over 10.
How we come
Miss,
by that?
so Miss 10 to, Miss you said 10 to the first power equal 10. So, so Miss you said 10 to negative 1 power, and you would get 1 over 10.
All right, so the law says when we're raising it to the negative power, we find the inverse, right? We raise it to that same power but invert it. So 10 to the first power is 10, and since it's negative, we put 1 over 10, inverse. Dresha, number 11.
Okay, miss. X to the negative 2. The negative 2 squared. I mean the negative squared. So miss, the law is that miss, when it's miss, when it's negative, miss, you'd invert it. So miss, you'd like flip it. So miss, x to the first group, miss, would be x. And then miss, to the negative second, miss, it would be x over 1 over x squared.
All right, so once it's negative, we're going to be inverting whatever the operation is. Okay, John, your turn.
Okay. This y to the negative third power equals 6 over y to the third. Make, make it the inverse thickness. Make it, make it the inverse thickness. Miss, that's how you get that. Miss, and miss you that
All right,
change the negative 3 to 3.
because it's at the bottom of the division sign, right?
Okay.
So we write back the 6 as a whole number up top, and since the y is being raised to a negative power, we know it's going to be down the bottom. So it's 6 over y cubed. All right, Imani, number 13.
Okay, Miss, number 13. 5x squared in bracket to the 4th power. Miss, so what we would do is multiply every single thing in the bracket 4 times by itself. So
Okay,
so first we would do it 5 by 5 times itself 4 times would be 625, and for x squared we would multiply the 2 by 4, because it says when you're multiplying the base, like when you're multiplying x to a exponent and you're multiplying it by a power, you would multiply the exponent and the power. So 4 times 2 would give you 8. So 625x to the 8th power.
correct. All right. So Dreshan.
Okay, miss. Negative. Oh, this mom is loud. Go into the other room. Negative x to the third power. Um, unless it's just in back.
Well, we're raising negative x to the third power. So it would be negative x times negative x times negative x.
Oh,
Mm-hmm.
miss, that would be miss negative x. Oh, negative x. Oh. It's negative x cubed.
So negative x times negative x will give a positive x squared. And then when you multiply that by another negative x, you'd get negative x cubed.
Yes, miss.
All right, John.
Okay, number 15. Bracket negative 3x close bracket cube equals negative 8x, negative 8x to the third. So, next, what you did was multiply negative 2x by 12 three times this, and I got negative 8x cubed.
So the first two negative 2's would give a positive 4. And then you multiply it by negative 2 again, you would get a negative 8. And then the x to the third power. Amari.
Okay, miss. Number 16.
Speak up,
Twen-
Amari.
Number 16. 26x y squared to the in brackets to the close the bracket to the power of 2 equal 606 676 x squared y to the fourth power. Miss you do 26 squared. Miss 26 squared equals 676.
How we got the 676?
Miss Miss 26 squared equals 676 and
Mm-hmm.
x to the 1 power times 2 equals x squared.
No, not times 2. We're
Wait,
raising the x to the power of 2.
okay.
And then for the y, so that's the y squared raised to the power of 2.
eh, And then yes, miss. And then you'd say, and then it would equal to y to the fourth power.
Okay. All right, back to you, Imani.
Okay, miss. 25 to the half power over 36. Miss, so when we get a number to a fraction power, what we do is we square the number the okay, how do I explain this? So the denominator would be what you're squaring the number how do you so 25
The
square root,
denominator is the root,
yes, the denominator
and
is the
the
root
numerator is the power.
is
Okay.
the power that you're going to put your answer by. So the square root of 25 is 5 and it's going to the 1 power, so it would be 5. And
Mm,
we're also doing the same thing for 36. So it would be 30 the square root of 36 to the first power, which is 6.
correct. All right, Dresha, number 18.
What is 9? But
Number 18.
oh yes, miss. Number 18. 14. But what's that?
49.
49.
Yeah, for
49
49.
over 81.
Oh, 49 over 81 to the negative half raised to the negative half. I Miss 49 over 81 to the negative half squared. So miss, since it's a negative
And
half.
by the way, that fraction should be in all brackets. Same for the fraction that we did prior to this one, right? So we put it in all brackets to show that we're raising the entire fraction to the power. So it's 49 over 81, and that should be bracketed raised to the power of negative a half. So explain how we would get the 9 over 7.
So since it's negative half, this you'd flip it, switch the inverse. Since it's negative a half, I'm missing the 81 over 49. And miss you'd cancel it, this which would be 9 over 7. Yeah.
Cancel it? No, we're not canceling
9 into 81, 9. Miss the square root.
Okay.
Yeah.
Square root of each.
And find the square root.
So you find the square root of 81 and the square root of 49. Because when you raise a number to the half power, you are to find the square root of it. The negative tells you that after you do that, you are to invert. Right? Are you there, Jason? Yeah. So remember, the brackets were left out for the fraction in number 17 and 18. They should have been completely in brackets, the entire fraction. So we're raising something to a fractional power. That means we're going to find the root. The denominator tells you the root, the numerator tells you the power. And since it's a 1 in the numerator, you're raising it to the power of 1, you'll get the same thing. So really, to raise something to the power of a half, you're really finding the square root of it. So it's the square root of 49, which is 7, and the square root of 81, which is 9. It would have been 7 over 9, except that it's being raised to a negative power. The negative tells you where to invert the fraction. So instead of the 7 over 9, we end up 9 over 7. John, number 19.
Okay.
Again, it should be in brackets. Yeah, the entire fraction will be in brackets. So we're raising, read what we're raising.
Okay. 8 over 27 to the negative 1 third. So, Miss, you'd find the square root of
Not the square
27.
root. This, not the square root.
It's the square.
No, John. If
It's
it's
the
a
cube of it.
half, it would be the square root. No, it's 1/3. So it's the cube root.
Yes, miss. Find the cube root of 27 and 8. Miss. If the cube root of 27 is 3 and the cube root of 8 is 2, so if you reciprocate the fraction.
You invert. Why do we invert the fraction?
It's because it's raised to the negative third. To
Okay,
negative
very
1
good.
third.
All right. All right, Imani, you take this one.
Okay, miss. So, oh, okay. Let's
So
see
read
now.
what we are given.
Okay, so we're given 8 over 27 to the negative 2 over 3 power. And so what we do with this one, we're going to find the cube root of, first we're going to find the cube root of 8 and 27 and raise it to the power of 2, and the cube root of 8 would be 2, and 2 to the 2 power would be 4, and we're going to find the cube root of 27. So the cube root of 27 would be 3, and the 3 to the 2 power would be 9, and because it's negative, we would switch the fraction. So 4 over 9 would be 9 over 4, and that would be our answer.
Correct. All right, Amari, take number 21, please.
Okay, miss. Number 21. 27 minus 1 over 3.
No, 20 is not 27 minus 1 over 3. 27 to the negative 1/3 power.
Negative 1/3 power equal 1 over 3.
How we get that? How we got the 1 over 3?
Miss, you'd say Miss, you'd say the cube root
The cube root of
of 27, miss.
which is what?
Miss, you'd say the cube root of 27 to the 3rd power. To 3, so. No, the cube root of 27 is
The
3.
cube root of 27 is 3.
And because it's to the negative 1 power, it would be 1 over 3.
Okay, so because it's a negative power, we invert the 3, and that's how we get 1/3. All right, thanks, Amari. Drayshawn, this is the last one, and it's yours.
Okay. 32 to the 2/5 power. 32 to the 2/5 power. So miss you would 2 to the so miss you would so miss you'd find this the the 2/5 root.
You'd find the 2/5 roots. 35th to the 32 to the 2/5. So when we're raising a number to a fractional power, the denominator tells us the root and the numerator tells us the power that we should raise that answer to. So that means we're to find the 5th root of 32 and raise the answer to the 2nd power. So, Drayshawn, what is the 5th root of 32? Which number, when you multiply it by 5 times, you get 32?
2 times 2.
2. And then you have to raise that now to the 2nd power.
This is just 4. It's 4.
4, correct. So remember, when you raise a number to a fractional power, the number at the bottom, the denominator, tells you the root. So you have to find that root of the number. In this case, the 5th root of 2, which is 2. The number at the top, the numerator, tells you the power that you have to raise number 2. So it's 2 squared, which is 4. So let's recap. the 6 basic rules that we looked at. And these are the laws of indices. So the first rule, when you're multiplying and the bases are the same, you add the powers, you add the indices. So x to the a power times x to the b power would be x to the a plus b. So we keep the base, we don't do anything to the base, but the bases have to be the same. We keep the base and we add the indices. Number 2, x to the a divided by x to the b is equal to x to the a minus b, which means if you are dividing and the bases are the same, we keep the base and subtract the indices. The third law, x to the negative a is equal to 1 over x to the a. So this means if you're raising the base to a negative power, you write the inverse. So it's 1 over that base raised to the power. The fourth rule is if you're raising a power to a power. So x to the a power, in brackets, raised to the power of b. You multiply the powers. Keep the base, multiply the powers. So it will be x to the ab. The fourth rule, any number raised to the power of 0 is 1. It doesn't matter how big or small the number is. It's positive or negative. It doesn't matter if it's a fraction or a decimal or a whole number. Once you're raising it to the power of 0, the answer is 1. And the last rule that we looked at tonight, a number or variable raised to a fractional power, where a is the numerator and b is the denominator. B tells you the root that you're to find, and a tells you the power that you're to raise that answer to. So x to the a over b is equal to the b root of x to the a. The bottom number tells you the root. So find the root. So if it's a 2 down there, you find the square root. If it's a 3, you find the cube root. If it's a 4, you ask yourself, which number, when I multiply it 4 times, I get this base. And when you get that root, you're to raise it to the power of whatever the numerator is. Whether you're going to square it, cube it, raise it to the 5th power, whatever that number is. These are the basic laws of indices, and you have to follow them. Remember, mathematics is a subject that is based on rules. And if you obey the rules, you will do well in the land of mathematics. So you start by first knowing the rules. And this is the reason why we are having this Thursday class, the formula class, where we go through the different formulas that are used and we break down how they were derived, why we use them, when we use them. Because once you know these formulas, remember, these formulas were handed down to us. We take them for granted, but you must remember that some of these simple rules, mathematicians took years, sometimes their entire lives, studying and experimenting and trial and error, dedicating their time and energy just to derive one formula. In some cases, their entire lives were spent throughout the centuries. Now you can take up a mathematics textbook today, and that textbook might have 100 different formulas. Don't take it for granted. Each one took years and years and sometimes lifetimes and centuries before that knowledge came to us or came to the scholars that were working at them at the time. So you need to take advantage of that fact that you can now take up a text, all of it is ready and waiting for you. So you only need now to find out, okay, these formulas have been derived. We understand now what the law is. So when do I use it and how do I use it? And that's what this class is all about. Remember, being Thursday, we're going to have our midnight class tonight. So that's from 12 midnight to 2 a.m. We're going to be doing our
Midnight
multiple choice
oil.
questions. Yes, we're going to try to do 60. Last week we were able to do 40. We're aiming for 60 this week. So get some rest and come back at 12, fresh and ready to tackle those 60 problems. Thank
Miss,
you,
why not do
scholars.
80?
My in-studio team, thank you for being with me. Yes, John?
It's
You're
me.
welcome, miss. Good night, miss.
Miss, why not just give them 80 questions, Miss? Miss, because last week, the man they finished them too quick.
Yes,
And
Imani did so well last week. She plowed through them. The exam is 60 questions. So that's our aim and that's standard. We're going to stick with that.
Please remember,
So hopefully we'll do the
math
60.
problems are changing lives.
All right. Always, Amarian, you always remind me of that. Thank you.
You're welcome.
We're not only solving math problems, we're saving lives. We're changing lives. And by changing them, we're saving them too, right?
Yes, miss. Yes, miss.
All right, so I'll see you in a few hours.
See you, miss.
Take
come on,
care.
say, Miss.
And
Bye,
Andre
Miss.
is going to join on Midnight Oil on studio.
Yes, midnight oil.